Good morning, Uncle Dries. Thank you for coming to visit us. And today we're going to have a tutorial about BitCare. And we are so excited to see what you can teach us today. Thank you so much.
Thank you, Randy. I think basically the previous time we had a general discussion about the drilling industry. Today we're going to be more specific on the specific problems and tools that we use in the industry. I'll talk as if I'm still behind a drilling machine, but I'm not. On MAF Trading, we supply spares and we supply equipment to the people in the drilling industry. But I'm dealing this because I had the same problems with the same equipment for many, many years. I think we start with a drill string. Now, if we talk about a drill string, for those who don't know, some people know, some people have more experience than others. A drill string is everything that hangs from the bottom of your rotation head right to the bottom of the hole. That's the bit. So we start with a bit coming up today. Now, if we think about a drill bit, I normally refer to electric drill that we normally use in our houses that most of the people know about. If you try and drill a hole into wood with a steel bit, you're going to battle. It's going to grip too fast. There's a specific drill for drilling into wood. There's a specific drill for drilling into concrete and into steel. The cutting edges are all different. Now, the care on a drill bit itself is basically the same. We need to take care of it. It's costly. A bit costs a lot of money. From the smallest, the bigger it gets, the more it costs. But when the holes are of a relatively slow depth, at a slow depth, or a shallow depth, the hammer is not that sensitive. But what an operator should do is try and keep the rotation smooth so the bit doesn't hook. Keep it smooth. You'll get the feeling when you're behind the controls. To over-drill a drill bit, I mean, if I want to drill a hole into steel with a drill bit with a blunt edge, you're not going to succeed. You're going to stand there for half an hour to drill through a 2mm plate. And you don't get lubrication. What happens? It gets red hot, it's friction. And the same with the drill bit on a rig. If you want to drill a hole in concrete with a blunt drill that's not sharpened, you turn too fast, your rotation is not right, what happens? That thing gets red hot. That's friction. If we get cold, we rub our hands together, what happens? Your hands get hot and you feel better. Now, friction, steel to steel, steel to concrete and steel to rock, that's friction we're talking about. Now, if we don't take care of the drill bit, we're not gonna get the maximum out of it. Sorry. The feed force and the rotation speed is very important. If I drill into softer formation, I can increase the rotation speed. Harder the formation, the slower the rotation speed. And with the down feed, the pressure that I use to drill, the operator should normally try and keep the bit down for the shank, the whole shank of the bit to penetrate into the hammer, into the chuck nut. Otherwise, we call it drifting, hold back of the drill, and that's when suppliers say to us, you've shanked your bit, the bit broke on the shank because you've been drifting. You didn't press too hard, you didn't give enough pressure. So if you're drilling to hard formation, slow down on your rotation speed. Otherwise what happens, it's a hard formation. The harder the formation, the smaller the chips that break. The tungsten on the bit needs to break the rock. The air blows it out of the way. If I turn too fast, I keep on drilling on drilled rubble. So you over drill. If you rotate too fast in a hard formation, you don't give your tungsten bits time to break the rock. You're trying to rub a hole into the ground, into the hard formation. What does that cause? Rubbing, friction, heat. That drill bit, I haven't measured the heat, the extent of heat that it gets up to, but if you look at a Cummins engine, 6-cylinder Cummins engine with a turbo that normally turns your compressor, in daylight, you see the turbo on that machine is a turbo. But in dark, that same turbo gets cherry red hot. It's like that all day long, but you just don't see it. But when it's dark, you see it. Now the only thing that cools that down is your air and your oil feed. It's designed to handle those heat with the correct coolant and the correct amount. So that drill bit, the friction it causes there, and what does heat do to steel? Heat damages steel. It changes the hardness of the steel. Heat and steel doesn't go together if there's not sufficient lubrication. So if I unnecessarily wear a drill bit, I am going to get problems. And as I said, with the over drilling of a drill bit, that tungsten button is totally round. And the round surface is the surface that gives you the less friction to the rock, between the rock and the surface. If that surface gets flat, if your button gets worn, and that surface gets flat, it creates more friction and more heat. Now I've seen some drill bits that the bit was drilled, that the tungsten, the flat on the tungsten is the size of the button. And according to all manufacturers and suppliers, we shouldn't drill a bit that the tungsten, the flat on the tungstens, is less than a third or more than a third of the diameter of the button. So if I've got a bit with a small bit with a 12mm button, 4mm are the maximum size of the flat, otherwise it causes too much friction. Now if somebody says to a supplier or manufacturer, this drill bit is not of the right quality, I want something else. If you haven't grinded that bit, if it's over drilled, no supplier, no manufacturer in the world will discuss anything further with you. They'll just look at it and say over drilled. Sorry, I can't help you. So we've got the pneumatic grinder that we sell with a diamond impregnated cups. So you can grind the drill bit if you use a 16 mil, 18 mil, 19, 20 button. You get the right size cups to drill that size of button. Don't use a smaller one, then you're going to damage your button unnecessary. And if grinding a bit, please take care not to grind too much away from the steel, the soft steel, the body of the bit. And if I look at a bit, at the shank, and I look at the bottom, the drilling face of the bit, I can more or less see what quality your operator is and how he takes care of his equipment. If the rotation is too fast, the flat face on the round button, the wear face of the button, if you're returning too fast, is on the trailing edge of the button. So it changes from the center to the trailing edge. If you drill too slow, it tends to be on the leading edge of the button. The size of the flat on the tungsten button indicates whether your operator grinds or not, whether he's taking care of his bit. The splines on the shank of the bit, the only lubrication that gets is when you put the chuck nut over the bit, prior fitting it into the hammer, the grease you put in onto that. Don't be scared that dust and trouble is going to bowl up there. You've got sufficient supply of air to blow that out, but it gives the shank time and it gives it lubrication until the lubrication from your lubricator comes through the rod, through the hammer and into the splines. So while drilling, the only lubrication your splines get is from the lubrication you send through your hammer. One thing to remember, even when rotating too fast, I'm damaging my splines. Because that bit goes up and down, the piston in the hammer, on normal circumstances, it travels about 25 times per second, up and down. We say within a minute, 1,500 to 1,800 times a minute, that thing travels up and down. Isn't that friction? Doesn't that cause heat? So if that poor shank doesn't get lubrication, it's going to wear. And in a chuck nut and on a bit, if the wear of the witness of the spline is lost by a third, so if only 2/3 is left, the supplier sees it as damaged. So if you drill after that, you're going to get problems. Don't expect to get a new drill bit. It's small things that we should look while drilling. I'm just looking here. And as I said, in the normal circumstances in the household use, we drill in wood, we drill in steel, we drill in concrete. We've got different drill bits in the drilling industry. We've got different kind of buttons. We've got different faces on the bits. You get a concave bit. That's the randomly one that we use. A concave because the bit tends to be hollow at the face. That centers the bit more. So I can drill a more straight hole, much deeper than with a convex. A convex is what we call a bullnose. That's a round nose. That goes much faster, but it deflects much easier. So if it hits a rock on the side, it moves away from the side. Where your concave, if your feed is slow enough, it eats away the side of that rock and it goes straight, or more straight than the convex. So I wouldn't use a convex to drill a water hole. I'll rather use a concave. We get flat faces for more corrosive materials. And remember, the amount of wear that we get depends on the rock formation that we drill. You get a highly corrosive rock like quartz, sandstone, that damages a bit. So, and it takes time to learn yourself, to teach yourself when and how deep can I drill into a certain formation before I must have a look at the bit to see if it needs grinding. I had holes that I drilled 200 millimeters, 20 centimeters. Then you're over 200 meters deep in the hole. Then you're in the quartz. That's heavy quartz. You drill 200 millimeters. You've got to remove the whole string to grind the bit. You have to, otherwise you can't go through the quartz. Now the biggest reason why people overdrill is they don't want to take the time to take out all the rods. Yeah, but I'm losing time, I can't finish the hole. But if you battle with a drill bit that can't drill, you're going to drill 4 hours to drill 20 meters. If I take it out, it's maybe going to take me 2 hours to take out, to grind half an hour, to put back another hour. And then at least I can finish the last 20, 60, 80 meters on that hole with a sharp bit without damaging it. So it's tit for tat. I take the time to remove the whole drill string and then drill a lot faster, much faster. That's how it should work. So that's, I just want to look if I missed something out here on the drill bits. But there's a lot of other things that we can discuss, what's very important on the drill bit is the stop ring. Some manuals call it a bit retaining ring, but stop ring. In the drilling industry we call it half moons. It's a half moon finish and clear. Now, most people don't know where to look for the wear on a half moon. If the edge, the round edge on the rounding of your half moon is dented or worn, or the thickness of the half moon is worn away, change it. Half moon doesn't cost you a lot. A bit, yes. If that wears out, when the bit stops, it tends to wobble. Call it wobble. I'm not English, but, and it doesn't hit the strike face of the piston flat. So I get a distortion in the hole, I get a distortion between my tools. That's when I shank a bit. So next time we'll have a look at the hammer, which is very, very important, which is much more expensive than the bit. But for the drill bit, as I say, we've got grinding equipment to grind it. Let's use it. Contact your supplier, find your supplier. If you've got a problem, ask. But prevent the problems that you can. Please, I've done it, I've been through it. I did the same. I've learned through it. Thank you. Next time we'll have a look at the hammer.
Thank you so much, Uncle Dries. When I was in the field, they explained to me, if you speak to an operator, a bit is like a wife. They don't like to change their preferred bit. So when you were drilling, what was your preferred bit? I know every scenario is different, but which one did you prefer?
I preferred the concave. The concave is the most random. You can drill a blasting hole. Blasting holes is normally not that deep. It's a shallow hole. So and that's why the blaster doesn't care if it drifts a bit, if it deflects. Because I'm going to load dynamite into it and I'm going to shoot it to hell. So if it's straight or not. But if you drill for water, they say this is the point. So they expect you to reach the point at the bottom. If they expect the water at 200, they expect you to hit straight from the top to the bottom at 200. If you deflect 5 degrees and you drill a hole 200 meters, how much are you going to be out at the bottom? Then the supplier is going to say, but you missed my water. It's your problem. So, but the most random bit we use is a down button. We get different size of buttons for different formations. But the concave is the the one we mostly use in South Africa.
Thank you so much for your time. We really appreciate it, Uncle Dries.
Pleasure.